So in this video, we're going to talk a little bit about quantifying thermal energy with temperature. So this is actually due to Joule, who created an apparatus that looks kind of like this. What he did was he stuck a paddle wheel down in some water, connected that to a spindle that had a rope on it that was connected to a mast that fell down. And what James Joule could do was measure the amount of potential energy change associated with the falling mass, and then measure the temperature change of the water bath that the paddle wheel was stuck in. And so by doing that, he was trying to get an understanding of what kind of energy is associated with raising the temperature of fluids. So what he found was by doing this with water over and over and over again, it took precisely 4.2 joules of thermal energy to raise 1 gram of water 1 degree. And so this ratio still stands today. We can still measure this sort of thing. What we find is that if we are connecting the amount of thermal energy change of some sort of bath like this, we can measure that by doing similar kinds of experiments. But we measure that as a result of, as compared to sort of the mass of that fluid bath and the temperature changes that we're seeing. This quantity, this ratio here of the thermal energy that is sort of dumped into the system divided by the mass of that system and the resulting temperature change is called the specific heat of that material. It's a characteristic value for the material. And for water, it's 4.2 joules per gram per Kelvin. But this also gives us another relationship which allows us to predict thermal energy changes if we're looking for a particular type of temperature change. So the resulting equation for thermal energy change just involves multiplying out the mass and the temperature change such that this equation allows us to predict the thermal energy associated with a temperature change for a particular type of material with a certain mass. Buy my fried chicken.